All right, welcome to section 2.5, and here we're going to be talking about percentages and fractions, and it's really mostly using percentages to solve problems. Now, percentages are actually exactly the same as fractions, but we're really looking at 1/100th as our unit fraction. So when we say 20%, it's actually 20/100ths. So whatever our little fraction is, the unit fraction is that we're using, and we need 100 of those to fill the whole. So if we're looking at percents, then we know that if this is a whole, then there will be 100 of those percents in there. Now, if we look at this picture now, we have these large pieces. Now, how many of them do we need to fill the whole? There's 1, 2, 3, 4, and then 5, that piece over there. So it would be 5 of them. So they're a fifth. So each one of these are 20%. Now, how much is this piece? Well, it's half of 20%, so we can say that would be 10%. So then this remaining piece is also 10%, and this is 5% because it's half of that. So if we wanted to add all of that up, would be 20, 40, 60, 80, 95. 95% are shaded. Okay, so determine the percent of the diagram that is shaded. And we can continue to do that. But the idea is that the pictures here represent the whole being 100%. So let's say even for question 4, these shapes represent a piece that you need 4 of to fill the whole. So each one of those is 25. So this is 25. Oops. 25%. So then this is 12.5%. The shaded region is 12.5%. You can work on the other regions as well. It's not a core activity, but it's good practice. Let's look at the core activity 2S, where it's asking us to use 2 different methods, so the picture and the percent table, to figure out a value of, let's say, 25% of 80,000. And it's giving us a lot of information and suggestions as to how to do that. Now, in addition to these, which you can practice and look at the textbook, I would like to show you another strategy, which I actually think is much more powerful than any of these. So it's a really good third model to introduce students to, the students that are comfortable with working with diagrams and working with percent tables. So, and what we do for that model is we use a percent thermometer. Now, if you remember thermometers, the good old thermometers where you could see that, let's say you have some kind of liquid and you put it under your tongue and it goes up and it says 37 Celsius and 98 point something Fahrenheit. So you can read either in the Celsius or the Fahrenheit your temperature, but your temperature is represented by this line. Now you can either read it as Celsius or Fahrenheit. Now it's going to be similar here in our situation because we're going to be looking at reading the amounts in 2 different ways, as percents and as some other number. So for example, here we're asked to calculate 95% of 80,000, and that's all I'm gonna do. So we have a percent on one side and some kind of a number on the other side. Now we have a place where we're measuring 80,000 items, whatever that is. Now, what percent is that? If we're asked to calculate 95% of 80,000, what percent is that? The fact that we have this of here suggests that 80,000 is our whole. And we know that the whole in terms of percent is 100 because each percent is hundredths, and we need 100 of them to fill the whole. So that's where we know we have a situation where 80,000 is 100%. And we're asked to find 95% of 80,000. We want to know that number. So let's see if we can play a little bit with this. So 95. So we know 100% is 80,000. Was it possible to figure out 50%? So you need two of these, right, to fill the hole. So wouldn't this be 40,000? Because if you do 40,000 and another 40,000, you would get 80,000. But that isn't really helpful. We know that 95 is 5 percentage points less. Could we figure out what 5% is? Well, if 40,000 is 50%, what if we take a tenth of that? Wouldn't it make sense that that's 4,000? So if we're going to decrease 5% here, we could go down 4,000 here to 76,000. And that would be our equivalent 95%. So do you see the strategy where we're representing the given information on our percent thermometer, and then we're playing with the numbers, trying to figure out different other equivalences. So if 100% is 80,000, then 50% is 40,000, then 5% is 4,000. You could have chosen to find 25%, right? Because it's half of the 50%. You could have chosen to find 10%. It's completely up to the student how they get to the values that they need, but all of those strategies would include some kind of partitioning or finding other equivalences. All of the questions that this textbook and other percent questions can be answered with a percent thermometer, and I think it's a very powerful model to use. So while I asked you to answer questions, all of these questions in this section, using the strategies and the methods that the textbook suggests, I would like to go through and give you this other strategy so that we can get used to that and learn to use it in the future for all other kinds of percent problems. So we need to calculate 15% of 6,500. So if we have percent here and the number here, we have 6,500, 6,500, and we want to calculate 15%. Well, again, the question is, what is 6,500? Well, 6,500 is our whole, so that would be our 100%. And we want to figure out 15% of that. So let's play with some numbers and find some other equivalences. So could we find 10%? We could, right? Because that's a tenth of 100%. So this would be 650. But how do we get to 15%? We need another 5%. Well, if 10% is 650, wouldn't 5% be 325? So if 10% is 650 and 5% is 325, we could add them to get to 15%, because remember, these are equivalences. So 15% will be 975. Right? So the double number line, or our percent thermometer, is actually working really, really well here. So let's see if we can use the same strategy for 7% tax on a $25 purchase. Okay, percent. Now we actually have dollars on the other side, not just numbers. So let's read the question here. Calculate 7% on a 25% purchase. Okay, so 7% tax on 25% purchase. $25 purchase. So we have a $25 purchase. That's our whole. That's the cost. And we're going to add 7%. All right, so this is our tax. Okay, and that's 107, right? So we need to know really how much this is. So let's see what we can figure out. Because 7%, we can find 50%. Right, that's $12.50. We could find 10%. That's $2.50. Right? Could we, none of that helps us get to 7. Could we find 1% perhaps? 25 cents is 1%. So if 1% is 25 cents, what would 7% be? Right? Well, 8% would be $2. So $1.75 would be what 7% is. So we would be, the tax that it's asking for is $1.75. If we were asked for the total price, it would be $26.75. But it just asks us to find the tax. So you see that for all of these percent thermometers, we're using the information that's given to us to plot it on the percent thermometer, figure out what it is that it's asking us, and then use our number sense and partitioning to figure out what that value is. So let's do the last problem on this page. So it's asking us to calculate 60% of 810. And I'm not going to read the rest, follow the rest of it. You can if you'd like, but with a number, with a percent thermometer, I like to give a lot more freedom for kids to use whatever strategy they want. So calculate 60% of 810. This is our whole. So 810, that's our whole, and we want 60%. And that's what we want to find out. All right, so we can find 10%? 10% is 81. Could we find 50%? 50% is 105. So what is 60%? Well, 60% is 50 and 10, so 60% should be equivalent to 486. Right? Okay, so I hope that gives you the an idea of how to use the percent thermometer to work with any percent problem. The second page of this activity is kind of not really relevant anymore, so let's try to go on to the 2T.